Hi and welcome. In this video, we are going to see about the question maximum sum of k consecutive elements of the array. Okay, and in this video, we are going to learn a new technique of solving some array questions. Okay, the technique is mainly used to reduce the nested loops into one single loop. Fine, for few particular questions. So what is the question that we are dealing with here is given an array of integers of size n and a value k, we need to find the maximum sum of k consecutive elements in the array. What is the meaning? For example, if n value is 5 and k value is 3, okay, and the array given to us are 4, 3, 1, 2 and 5. Okay, so we have to find the maximum sum of k consecutive elements. How? K consecutive means 3 consecutive elements in this particular example. So 3 consecutive elements. What is the sum? 4 plus 3 plus 1, that is nothing but 8. Then 3 consecutive elements, 3, 1 and 2. What is the sum? 3 plus 1, 4 and 2, 6. Then 3 consecutive elements. What is the sum? 5 plus 2, 7 and 1, 8. So can we go ahead? We do not have 3 consecutive elements after this point, so we will not go ahead. So in this particular example, the answer is nothing but 8. For k consecutive elements, the maximum sum we get is nothing but 8, either in this 3 consecutive elements or in this 3 consecutive elements, that means 3 subarrays. Okay, so this is what the question is. Given one more example, if n equals to 7 and k is nothing but 4 and the values are 4, 5, 1, 3, 2, 6, 7. So 1, 2, 3, 4, 5, 6, 7. So what we need to do, we need to find the maximum k subarray sum. Okay, so this is one of them, this is another, then this one 4 elements, and then this one 4 elements. So we will have these 4s. So what is the sum? So when we sum it out, so these are my sums. So here is the maximum sum, that is 18 for the k consecutive elements, 4 consecutive elements, that are 3, 2, 6 and 7. So we have to find this sum. Okay, so this is what the question is. Now let's see the approaches. So first we will discuss the basic approach, the brute force approach. Okay, and second we will discuss an optimized approach and the technique that I was telling you about. Fine, so let's see the brute force approach now. Let's see the brute force approach now. In this particular question, okay, in this particular test case, what do you think is the most basic approach for this finding out the maximum sum? Okay, if we start from this, okay, and k value is 3, so get the first 3 elements, so 4 plus 5, 9 and 10, store it, the sum, store it some variable. Okay, now get to the second index and get the next 3 elements, okay, the 3 elements, and store the sum. So 5 plus 3 is 8 and 8 plus 1 is 9. So is 9 greater than this? No, so do not update it out. So get the next 3 elements then. Okay, so what will be the next 3 elements sum? Is it greater? No, so do not leave it that way and continue like this. So for each index, okay, we will need the next k elements. We will need the k elements. Okay, for each index we need the k element. For each index we need the k element. Okay, so we can use a nested loop here directly. For each index we will go to the next k elements and we are done. Okay, we will update our sum value, that is the maximum value. Fine, so this is the most basic approach to solve this problem. For how it will happen, for each element we have to go to the next k elements and sum them out. Fine, so let's just write it down. Okay, for I equal to 0, that is the first index, for I equal to 0, okay, till where we will go, we will see this, till where we will go. Okay, I plus plus. So for the first index, okay, let's have another loop, j equal to I. Okay, j will begin with I, the index that we are at, j will begin with that. Okay, j will go till I plus k. Fine, I is 0, k is 3, so 0 plus 3 becomes 3, so we will go till less than that. So less than I plus k, not equal to, not less than, equal to, less than. Fine, if I is equals to 0 and k is 3, so 0 plus 3 becomes 3, we have to go before it, 0, 1, 2, 3 elements. Fine, and j plus plus. Now if I equal to 1 and k equal to 3, so I plus k becomes 4, and we need 1, 2, 3, we need to go to 3 index, that is less than I plus k. Fine, so from j equals to I, the current element, and less than I plus k, fine, we have to find the sum. Sum equals to sum plus ARR of j. Okay, so we will add for I equal to 0, so j value will become 0, so first 4 will be added. Okay, then j will be incremented, fine, then 5 will be added, so 5 plus 4 becomes 9, then j will be incremented, j value will become 2, so 9 plus 1 will become 10, and at the last when j is incremented, j value will become 3, and 3 is not less than I plus k, so therefore this loop will break, and we have to update our sum max, update the max, fine. So this is how this is going to work. Okay, now till what element do we have to update I, increase I, till what element? Fine, so let's see here, I plus k, we need j to go till I plus k, so there should be I plus k elements left. For example, if I value is 5 and k value is 3, so I plus k becomes 8. We do not have that many indexes, we cannot go till that point, so we do not have to consider those indexes. Now if I equals to 4 and k equals to 3, we need to go till 7, but we do not have 7, fine, we need to go till less than 7. Yes, less than 7 is available, so for this case we will go inside, we will definitely go inside, but for this case we will not go inside, because less than 8 is nothing but 7, and 7 is not available, so till where we have to go? We have to go till I plus k minus 1. If this value is less than n, n value is here is nothing but 7, okay. If I value is 4, k value is 3, 4 plus 3 is 7, minus 1 is 6. Yes, 6 indexes are there, 6 is less than 7, this is true, so we will go inside and we will get the sum of 4 plus 5 plus 6, fine. So this is how it is going to work. So for I equal to 0 till I plus k minus 1 less than n, okay, till it is possible, we will increment I, and for each possibility we will go to j and we will start with I and less than I plus k. This I have explained, and we will get the sum. After this j loop is over, we will update the max. Okay, if this current sum is greater than the max, then we will update it. Fine. So this is the brute force method. Let's write this down. So this is the brute force that we have discussed till now. Now take all the inputs, declare a max variable. Now this max equals to minus 1 if there are no negative elements in the array. If there are negative elements, this max should be declared with what? The minimum value of integers. Okay. Now sum equals to 0. Fine. Now for int I equals to 0, till I have explained this point, I plus plus, make sum equals to 0 before going to j loop each and every time, because this sum is nothing but the current window sum. Okay, so if we have 4, 5, 6, 7, so first this is the sum, then this is the sum, correct? So it should be initialized with 0 each and every time before going inside our k consecutive elements. Now this sum will be calculated. Okay, I have explained this. Now if sum is greater than max, if this current sum is greater than the max, then we will update the max. Okay, and finally we will print the max. So this is the brute force method. Okay, now let's see how many operations will this method take, and then we will move on to our optimized approach. Okay, let's see the number of operations that this code is going to take. So I plus k minus 1 less than n, we can write it as I less than n minus k plus 1. Okay, so the outer loop will run for n minus k plus 1 times. The inner loop is always running for k number of times. Okay, whatever is the value of k. Now what we will do? So since these are nested loops, so it is nothing but n minus k plus 1 operations multiplied by k operations each and every time. Okay, the outer loop is running for n minus k plus 1 time, and inside we are coming, so this is what k number of operations. So in total what we got, n minus k plus 1 operations of the outer loop multiplied by k operations of the inner loop. For each of the operation of outer loop, the inner loop is running k number of times. Fine, so therefore multiplication. Now let's see some values and see given the constraints how this will work. So if n value was 10,000, suppose the maximum size of the array given to us is nothing but 10,000. Okay, and k is 5,000. So what this equation becomes? 10,000 minus 5,000 plus 1. So it is nothing but 5,001 multiplied by 5,000. So this becomes nothing but 25 and 6 zeros. Correct? 1, 2, 3, 4, 5, 6. Okay. So these are many number of operations. we got, that is 2.5 I think, or 25 into 10 to the power of 6. Okay, these many operations we got. Now if n is nothing but 1 2 3 4 5 and k is 50,000, okay, so what will happen now? It is nothing but 50,001, okay, 50,001 multiplied by 50,000. So it is nothing but 25 into 10 to the power of 8. 25 into 10 to the power of 8, around this many number of operations it will take. Now if I increase n by 10 to the power of 6 and half it out, it will be 5 into 10 to the power of 5. So this will go to 25 into 10 to the power of 10. Okay, now see, so many number of operations for n equals to 10 to the power of 6. This will be around the constraint that will be given to us in such questions, okay, and can be 10 to the power of 7 also. Fine. So we cannot have these many number of operations if the time limit given to us is just 1 second. Okay, we cannot have these many number of operations of 10 to the power of 10 range. Fine. So we need to optimize it. We need to reduce the number of operations somehow. We need to reduce the number of operations. Okay, so let's now see the technique that we are going to use to reduce this number of operations. Okay, and then we will code that technique. Fine. Thank you. So to reduce the number of operations, we are going to use sliding window technique. So how this technique works? So let's suppose k value is 3. Okay, so we will have a window of size 3. We will have a window, as you can see in blue color, this is the window of size 3. Okay, let's sum. So 4 plus 1 is 7, 7 plus 3 is 4 plus 1 is 5, 5 plus 3 is 8. So sum of this window is nothing but 8. Okay, now let's slide the window to the next 3 elements. Now if you slide the window to the next 3 elements, that is, now the window is here. Okay, now the window is here, correct? So from 8, that is the sum that we have just calculated before. From 8 now, which element we reduced? So 8 was formed from 4 plus 1 plus 3. Okay, now if we slide the window, this 4 disappears. Okay, just think that we can only see the elements that are present inside the window. Okay, we cannot see other elements. We can only see the elements that are present inside the window. Okay, so now 4 disappears. Now since 4 disappears, so from the sum we have to subtract 4. Okay, so we have 4. Fine, 8 minus 4 is 4. Now 5 appears, 4 disappears and 5 appears. Okay, so from the remaining we have to add 5. So the sum we will get is nothing but 9. So for this red window, the sum that we got was 9. Okay, now if I slide the window again, fine, so I'm sliding it again like this. Now this is the green window. This we have is the green window containing 3 elements. Okay, the window size will be same, 3 of k. Fine. So now in the green window, we can only see the elements that are present inside the green window. Okay, so from 9, 1 was discarded. So we got the sum as 8 only, and 8 was added. 8 was added inside this window. We can see 8. We cannot see 1, so we subtract it out, but we can see 8. So 8 plus 8 becomes 16. Okay, so in this window, the sum is nothing but 16. 8 plus 3 plus 5. Fine. So the sum became 16 now. That is for the green window, the sum is nothing but 16. Fine. Now let's move forward. And let's see. Now in the yellow window right here, like this. So which element is now not visible to us? 3 is not visible. So from the sum we have to subtract 3. So 16 minus 3 becomes 13. And 9 is visible. So we have to add 9. Okay, 13 minus 9 becomes 22. So in this window, the sum is nothing but 22. Okay, I hope you understood the approach. What we are simply doing is, we are calculating the sum of a particular window. Okay, which element is removed from the window, that element we are subtracting, and which element is added inside the window, that element we are adding in the sum. Okay, so this is how the process goes. Fine. The element which is removed from the window, we are subtracting that element from the sum, and the element which is added inside the window, we are adding that element to the sum. Okay, so this is how we are moving forward step by step. Okay, now since it is 22, now in the next window 5 will be removed, so 22 minus 5 will become 17, and 2 will be added. 17 plus 2 will become 19. Fine, this is how we are going to move forward. Now in this all things, the maximum value that we get is our answer. We will store the maximum value, and the maximum value we'll get is the answer. Okay, so I hope you understood this sliding window technique. Okay, we can only see the elements that are present inside the window. So if the element is not inside the window, we are going to delete that from the sum and add the new element, fine. So this is how this technique works. So let's now see the implementation of this technique. Okay, what are all the variables we need? Okay, what will be the conditions in the for loop, and so on and so forth. Fine, let's see that. So the first thing that we need is the sum of the first window. Okay, so k value we have 3. So sum of the first window is the first thing that we need. So we can directly calculate it. A loop from I equal to 0 to I less than k. Okay, 0 to less than k, k value is 3, so less than k, I plus plus, and in this the sum plus equals to ARR of I. So it is simple, we get the sum of the first window. Okay, now we are going to slide it. Now we are going to slide it in a different loop. So this is done. We got the sum of the first window. Let's store this sum in the max variable. Okay, and have sum equals to 0. Now this sum will represent our current window sum. This sum will always represent the current window sum, and max will represent the maximum sum that is present till this point. Okay, so therefore I am doing sum equals to 0. Okay, so let's now begin. Now from 4 I equal to, from which element we need to begin? Now from which element we need to begin? Just see that, from which element we need to begin. Do we need to begin from this element, or do we need to begin from this element? Now this is an important point. Why? Because we just need to add and delete and nothing else. We need to delete few points and we need to add few points, correct? So let's begin with I equals to k. That is, we need to add this. We need to add this inside our sum. Okay, and we need to delete this from the sum. Correct? When the window is slided, we need to add this inside the sum and we need to delete this from the sum. Okay, from I equals to k till where we will go? We will see I plus plus. Okay, so the sum that we had, we made it 0. Okay, so we do not have to make it 0. We do not have to make the sum 0 because we need it. We have to decrement and increment in the sum itself. So this was a wrong point, so we do not have to make it 0. So sum equals to sum plus, so what we need to add? We need to add the element pointed by I, ARR of I. And what we need to delete? We need to delete the element that is removed from the window. So how do we find it? It's actually very simple. It is nothing but I minus k. Why? I value is 3, k value is 3, so 3 minus 3 is 0. If I value is 4 and k value is 3, so 4 minus 3 is nothing but 1. So as you can see, if I value is this, that this is the last element of our window, then this is our total window of 3 elements. So 1 is removed, so 4 minus 3 is 1. Okay, 3 elements before it, k elements before it. Okay, understand this way, k elements before it. So minus ARR of I minus k. Fine. So this is how we are going to do it. So we will get the sum like this. Now if this sum is greater than max, if this sum is greater than max, so max equals to sum. So this is how we are going to store the maximum sum till now. Fine. Now till where this loop will run? This is actually simple, I less than n. Why? Because we are incrementing I one by one. So we will go till the last element. We will go till the last element, and for this element, this will be the window. Okay, so I value is 6, k value is 3, so 6 minus 3 is nothing but 3. So that means this element was discarded and this element was added. Therefore sum plus the current element minus the discarded element. Fine. This is how the whole window and the loop is going to run. Fine. So this is the code. Fine, I will just show you how this code is running by writing it down. Fine, and then we will move on to the actual implementation. Let's see this. So in the beginning, I value is 0, so I is pointing at this position. K value is 3, so k is here. K, that means k is 3, so I is 0, so sum equals to array of 0, so sum value will become 4. Okay, then we loop again I plus plus, I value will be pointing here, sum value will be 4 plus 1, that is nothing but 5. Then I plus plus, I value will be pointing here, sum value is nothing but 8. Okay, then I plus plus, when as soon as I points here, this condition becomes false and we will come inside, we will go outside, and max will become equal to sum, so max value will become 8. So at this current position, sum value is 8 and max value is 8. Okay, so now sum is 8 and max is 8. So what this sum is representing? The sum of the first 3 elements, the first k window. Okay, and what is the max? That is the maximum number we get till now. Now let's move forward. Now I value will become how much? I value will start with k. I value will start with k. So what was k? K was nothing but this, correct? 3. So let's begin this. So I is 3. So array of I is nothing but 2. So some value, we are inside this, I is 3. So sum equals to 8 plus array of I, array of 3. Array of 3 is nothing but 2. So 8 plus 2 minus array of I minus k. I is 3, k is 3. So 3 minus 3 is 0. So we will minus this element 4. So the sum we got is nothing but 6. Okay. So since the window slided, this element disappeared and this element appeared. So we add that element and we subtract the disappeared element. Okay. Is 6 greater than 8? No. So we will not update sum. Okay. We will not update max. Sum will be updated. Now, next. After this, I value will become 4. I value will become 4. So for I value equals to 4, that is I is now here. So sum equals to 6 plus, that is the updated value, 5. The current value I is pointing to, minus I minus k. I is pointing to 4, k minus is 3. So 4 minus 3 is nothing but 1. So array of 1 is nothing but 1. So 6 plus 5 is nothing but 11 minus 1 is nothing but 10. So for 3, 2 and 5, we get the sum as 10. Okay, so this will be updated. Is 10 greater than 8? Yes. So this will also be updated. So this is how the whole loop is going to work. Okay, each and every time a value will be added and a value will be subtracted from the previous sum, and each and every time we will check whether this current sum is greater than the max or not. If it is, we will update the max. Now how many operations here? So this is k number of operations and this is n number of operations. So this is nothing but n minus k number of operations, because we will start with k. So this is nothing but n minus k plus k. Okay, so this is nothing but total n number of operations we get. So if n is nothing but 10 to the power of 7, so we have only 10 to the power of 7 number of operations. Fine. In the previous case, if n was 10 to the power of 6 also, we get around 10 to the power of 10 number of operations. Okay, so we have reduced it a lot. Fine. So this is the optimized approach and the sliding window technique that we are going to use, that we have used in this particular problem. Okay, now I'm just going to code this down. Okay, the same thing, but I'm going to code it in an IDE and run it for multiple test cases to show you that how it works. Okay, so let's see the implementation part now. So n and k, I have taken test case 2 for testing it for multiple test cases in a single time. Okay, so now n input, k input, an array of size n elements in the array, maximum and the current sum. Okay, current sum be 0. Now just a for loop for int I equal to 0, I less than k. Okay, so this is the sum of the first k sub consecutive elements. Fine. So current sum plus equals to ARR of I. After this, max equals to current sum. Fine, we have discussed this. Now for int I equal to k, I less than n and I plus plus. What we are going to do, we are going to add into our current sum the element that is just now added inside our window, that is the element I, and we have to subtract it the element that is gone outside the window, so I minus k. Fine. If current sum is greater than max, then update the max. Max equals to current sum. Okay, after this, just print the max. So this is how it's going to work. Fine. Let's now just run the loop and see, run the program and just see. Fine, we will test it for multiple test cases. Okay, you see the test cases that I am testing it for. Okay, you have to test it with different programs. We have different test cases, but you have to think what can be the corner cases. Okay, so if the length is 3 and k value is 1, so the answer should come as the maximum element inside the array. Okay, if length is 3 and k and n are same, so the answer should come as sum of all the elements inside the array. Correct. So if we have 5 and 5, so it should be all the elements inside the array. Fine. Now if we have 4, if we have a single element inside the array, okay, so k value will be 1. Okay, k will never be greater than n, and that single element should be the answer. Fine. So some random test cases, 5, 6, 1. So the answer is nothing but 12 and 2, 5 elements. So the answer is nothing but 17. Okay. Now 5 and 4, and so this is how we are going to see it out. Fine. So these are many test cases that we have tested it for. Okay, if you are getting a wrong answer, every time you have to test it at least for 10 and 20 test cases. Okay, then you can find out whatever is wrong inside your code. fine. And then you have to try run your code as well. The dry run we have already done. Okay, I have performed the dry run of this code. How this code is actually working, I have shown you that you have to perform also. Fine. So this was this particular problem and the sliding window technique that is used in many questions to reduce the number of operations, to reduce the nested loop into a single loop. Fine. Thank you.